Welcome. This is a tactical technician video from Diagnation, and today we're gonna, I guess we titled this video battery terminal voltage drop, and we're gonna key in on the battery terminals because it's so important. And what you see in front of you is a tool I made, very simple. And what the advantage of this tool is, these are plastic clamps. You can see the green and the red one. They're completely insulated, and I ran a machine screw through the side of one. So when we actually hook to the battery, we're right on top of the battery post. We're not going to be on the clamp this time, and we're going to be able to look at multiple channels on the scope, and we'll be able to keep our hands free. That is so important as a mobile tech or somebody working, doing a no start or a drivability issue. It's always important we check the battery, that we keep our hands free, so we'd be able to crank the car or be able to do something. So many times you see people holding probes against the post and against the battery terminal, and then somebody else cranking the car, and you're doing a min-max on a DVOM, which is a good tool, but the scope is so much better because we see so much more action in a smaller window of time. We can look at our voltage drops. So anyway, I will go to the battery with these things, and I'll hook them. I'll show you what they're doing basically. You can take a look at the battery. The positive terminal is original. The negative terminal is fairly new. That's a good lead terminal to a lead post. That metal, that positive thing is metal. And anyway, so I'm going to start out with the red one, and I will hook it to the battery, and you'll see what happens here. We get right and we clamp it, and we're stuck there, which is good. We got our screw hitting the lead, and then we got our clamps actually holding it to the battery. Our clamps are all insulated. They're non-conductive, so we're just tapping off the battery post. So now we do the same thing on the negative side, and we clamp it. Okay, we're clamped there. And we just got to be mindful that the stud never lifts up. That's a variable. Obviously, that can happen. I did a lot of dry running and testing, and the stud stayed in good contact. I always recommend doing it with a pointed stud, something sharp, a machine screw or something. But you can come up with ideas. So we have the two tools adapters on the battery. Then we're going to hook the scope leads across them. We're going to check the voltage drop across the battery terminals. And this can be done in different ways. It depends on where you suspect voltage drop is. At least you have one terminal right at the battery post, so you can prove out that the actual terminal is good. Over here we have two loads. We're going to do this in three different segments. The first we're going to do cranking, and then we're going to look at voltage drop across the positive and negative terminal, and also the amperage coming out of the battery. And over here we're going to look at we got about an 18 amp test light that pulls 18 amps, and we have a kind of a battery tester, an old school toaster style heat battery tester. We're going to pull about 80 amps. So basically we're going to look at a situation where we want to prove out those connections. If we ever have a no start and sometimes we can't crank it, we want to see where the circuit could be compromised. So with these two load testers, we're going to do one at a time. We're going to hook across the underhood fuse box to the engine block. So basically it's a complete circuit coming out of the battery to the underhood fuse box, to the engine block, and off the ground back to the negative side of the battery. We're going to do that with these two loads. And the first one we're going to do without that, we're going to do it cranking in its natural state. And we're going to see what it looks like, and we're going to analyze the voltage drop. So I'll get you the scope. We got three channels on the scope. We got the red, which is the positive battery terminal voltage drop, the green, which is the negative terminal battery voltage drop, and the blue, which is a high amp clamp around the battery that will look at the current coming out, because we always know whenever current is flowing, voltage is dropping. Bear that in mind. So we'll see the relationship of when the current is flowing. So we'll kind of take a capture. We'll crank it for a good maybe 10 seconds, and then we'll see what's going on. Okay, we lost our green guy. Got to hook the scope up. Always those things we shoot live. The green terminal to the tester, and the red terminal. So that's important. You got to hook the scope lead to those things I told you I made with the battery, the adapters. Okay, so now you can see we're running across the screen. We got green and red is the battery terminal voltage drop. We're on 200 millivolts per division on red and green, and we got the current clamp, the high angle clamp around the battery. So we'll take let me stop the scope, and then I'll start it and get to the, I'll crank the car about 10 seconds, and we'll see what's going on. Okay, here we go. Okay, we had some action there. We have the current was flowing. We saw it. We'll go back to the original. Basically, it looks like relative compression, and I missed the Russian spike. Probably could have set a trigger, and nonetheless, just looking at these guys here, I'll take the voltage drop. Our current, our kind of plateauing current, other than the Russian current, we're about 140 amps. Our voltage drop on the battery positive terminal from the post to the actual battery terminal, that's 42.26 millivolts. To me, that's excessive, because you'll see why. Let's compare it to the negative. The negative terminal, and now it's the same current flowing about 2 millivolts. So when at the beginning of the video, you saw the age of that terminal. I kind of wish I had a brand new one I could change now and then reshoot, but nonetheless, just get an idea of that the difference of voltage drop on a battery terminal, that it's much more excessive on the positive than it is on the negative, with the same current flowing. So let's do one more thing. I just want to set a trigger so we can kind of look at the Russian current, because that's when the current is max. And I will set the trigger on A, and let's get her up to here. I'll pull this guy here, and then I want to see the Russian current. I'm gonna go about a third of the way across the screen, and then I will crank, and then we'll take a look. Okay. 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 Here we go. Okay, we see our Russian current right here. Pretty high. I mean, we're north of 600 amps. The clamp only goes to 600. We know that's kind of when the starter is just starting to move. But take a look at our voltage drops. Let me get the blue out of there. You've seen that. You've seen the relative compression. Take a look at the voltage drop right about here. That's 173 millivolts. It comes down as the starter reaches its normal crank to about its 40 and change here. So you see that. And then, of course, our green is that got to 23 millivolts on the Russian. That's when current is really flowing. It kind of comes down and plateaus and settles to about 2 millivolts, which is I would definitely deem that good. I would deem the red side the positive side a bit high. So nonetheless, we're gonna change situations here. We're gonna go to the two other situations. We're gonna start this. I want to get rid of the trigger because I won't be getting that spike anymore. So I want to get back to normal. I'm going to start out now with the 90 amp load. Have you ever had a situation where we had a no start or something, and we couldn't use the starter as our drawing medium? We're going to have to put a load in there to see what our voltage drop would be across the terminal. So I'm going to close the switch on that battery tester, and we'll see our current and our voltage drops on the positive or negative. Okay, you see that? We'll stop the scope and take a look at what we have. Okay, our current's flowing here. That's when we're going to be I'm going to say about 82 here, 82 amps. Of course, 82 amps is not as much as the starter draws, but nonetheless, we don't see the relative compression because it's a different kind of load. Now, it's not the starting motor. It's more of a different kind of a pull. It's more level. We got about 2491 millivolts on the positive battery terminal on red, and on the green we're about, wow, that's I'd say about Okay, that's when I see the UV on a Pico, that would like microamps. Okay, let's kind of key in on it, and I'll stretch it for the grins. Okay, 2.93 millivolts. Okay, that's with the 90 amps flowing. So anyway, let's do our final draw test. We're gonna do it's about an 18 amp pull. Now, if we were in a situation where let me get everything back to zero. We have a good baseline. Where we had a no start and we were suspicious that we wanted to prove out the connections. I'm gonna go a little longer time base. And so we had our high amp test light, and we're gonna put it across from the fuse box to the block, just to get a better idea of the battery terminals, because we're set up to check voltage drop. We can shake terminals, we can pull on cables, just to see if it's intermittent, if vibration is affected. But nonetheless, here we go. I'm gonna run that 18 amp test light right across the underhood fuse box. Okay. See, we're flowing. I'll kind of break the contact so you can see. Okay. Now stop the scope. Now we're okay. Here's our draw. It's about, well, it comes down, it rushes in about 20. Probably not super accurate. I'm using a high amp clamp, and I probably didn't zero it. The delta would be, I know it's between 18 and 20. Okay, so basically we're looking about, let me get it right here, I'll call it here. Okay, 18 amps right there, you can see that. Okay, we're drawing about 18 amps. Now our voltage drops. In a situation like this, we may want to shake terminals, want to see, right now we're about 5.8 millivolts. That's on the positive terminal. Again, it's all in proportion. The more current, the more voltage drop we get. So we can see that as this one is going to be real low. Yeah, then I see UV, that's microvolts. That's millivolts right there, I'm going to say. Okay, that would be microvolts when you see the UV. That's microvolts, and that's millivolts. Nonetheless, I will take a look, and you could see, try to get it. I'll stretch it just for the grins to get a better look at it. And so we're here, and we kind of plateau from 1 millivolt into the microvolt range. Nonetheless, this is our setup, and keep this in mind. It's so important to check battery terminals, and the way we do it here, we kind of isolate that top post from the rest of the cable, because I've seen so many times where people put alligator clips on the battery, and you're partially on the post, you're partially on the outer terminal. So anyway, signing off, and remember that you can make this tool. I'll show it to you one more time. I went to Harbor Freight to get the clamps, and then put a little hole in the outer end of them, and that's how I made the tool. Anyway, just a little clamp from Harbor Freight. And okay, thanks for watching. Take care.